A very warm and pleasant good morning to you all children. Now I welcome you to this week's process of learning. Hope everybody is safe and everybody is fine, hale and healthy. Children, we are going to see today about a new chapter, and it is a fundamental chapter in chemistry. And the name of the lesson, not the lesson, we can call it a subtopic of a lesson. So the subtopic name is structure of an atom. So we are going to see this in detail, and everybody should know about the structure of an atom. It's very fundamental. So you have to listen very carefully each and every slide, and you have to proceed further. In chemistry, a few fundamental things you must be well aware of so as to understand the concepts which you are going to learn in future. If you lack in the fundamentals, then chemistry becomes difficult for you to get understand. And this chapter, the structure of the atom is very, very basic, and you should have a strong knowledge of it. And that's why I am insisting you to listen to the slides very carefully and follow and understand what is given here. Okay children, now let us move to the next slide. Let's go to the next slide. Come on please. Yes children, listen to me very carefully. We will see one by one. And if you don't understand, just keep on listening to the same until you get understand. Structure of atoms. First let us see what is structure. Now when you look at a chair, you can tell its structure, saying that it has four legs, it has a seating platform, and it has armrest and the rest for the back. So these are the structure of the normal chair that we are sitting in. Similarly, what is the structure of a tree? So we can tell simply it has a big trunk, and above the big trunk it has branches, and in the branches you have bunch of leaves with flowers, etc. etc. So structure describes the object that we see. So whatever be the objects that we see, we can describe their structure very easily. Now let us see what is an atom. An atom is the smallest constituent unit of ordinary matter that constitute a chemical element. Every solid, liquid, gas and plasma is composed of neutral atoms. Atoms are extremely small. Typical size are around 100 pictometers. So this is what the structure of the atom says. So an atom is the smallest particle of a matter. Matter we have already discussed in the earlier chapter. So matter consists of solid, liquid and gas. And in all these states of matter, if you go on dividing that matter into two, you will get an position where you will not be able to break it further, and that part of matter is called an atom. An atom is a smallest particle of a matter which cannot be divided into further. Can we see through our naked eye? Definitely not. We cannot see an atom through our naked eye because its size is very, very, very small. It is around 100 picometers. So you will learn about it in higher classes. So what is an atom? An atom is a smallest unit of matter, and it cannot be seen through our naked eye. It can be seen only with electron microscope, not even ordinary microscope. The microscope you would have seen in the clinics by the biologist to examine your blood group and other things, or in the our labs also are having compound microscopes. Through those microscopes also we cannot able to see the atom because their size is still small. Through a special device which is called as electron microscope, we will be able to see an atom. Now let us come to the structure of the atom. Previously we have seen the structure of an ordinary chair which is visible. Now we are going to tell about the structure of atom which can be seen only through an electron microscope. So when you look at the diagram here, it consists a center part, and this center part has plus sign and also with some color of green, and that part it is the center of the atom, and the center of the atom it is called as nucleus. The center of an atom is called nucleus. And there are three types of subatomic particles in an atom. An atom consists of three subatomic particles. What are they? You can see in the color codes. Electron, which is indicated by a minus sign, proton, which is indicated by a positive sign, and neutron, which has no sign. So an atom has three subatomic particles. They are negatively charged electron, positively charged proton, and with neutron, which has no charge. And now look at the nucleus. What is the nucleus made up of? The nucleus is made up of the green color neutron which has no charge. Along with that you have positively charged proton. So what is the charge of the nucleus now? It is positive because protons are there with neutral neutrons. So the nucleus is positively charged. And what are the particles present in the nucleus? It is neutrons and the protons. And that's why these two particles are collectively called as neutrons. Neutrons means the particles which make the nucleus. So which are the particles which make nucleus? Look at the center. You have positively charged proton and the neutral neutrons. So in short we can say an atom consists of a center part called nucleus. The nucleus is made up of positively charged proton and with no charge of neutrons. Therefore the nucleus itself has positive charge, and the particles in the nucleus, they are called as nucleons. So which particle constitute nucleons? Protons and neutrons make up the nucleons. Okay children, now let us move on to electrons. Now come out of the nucleus. You have a circle where two electrons are there with a negative sign, and up next to it you find one more circle. These circles represent shells, and these shells are revolving around the nucleus. They are not stationary, they keep moving or they keep rotating where electrons are in that. So outside the nucleus you have a number of shells, where electrons are placed in the shells and those electrons keep revolving around the nucleus. Okay children, now you got what are electrons? Electrons are negatively charged particles which are in different shells outside the nucleus, which keeps on rotating around or revolving around the nucleus. They are negatively charged. Hi students, this is another slide which explains you the same concept of what you have learned in the previous. What is the structure of an atom? Proton, neutron and electron are not evenly distributed in an atom. That's what you are going to see. They are not, these we have seen that there are three subatomic particles, protons, neutrons and electrons, but they are not evenly distributed in the atom. The proton and neutrons exist in a dense core at the center of the atom, and this is called the nucleus. As I told you, you look into the center part of it, you have green colored and red colored particles, and together this part, the center part, is called as nucleus, and it consists of protons which has positive charge and neutrons which has no charge. Then come to the next point. The electrons are spread out around the edge of the atom. They orbit the nucleus in layers called shell. So as I have told you earlier, around the nucleus we have a number of shells where electrons are fixed and they keep on revolving around the nucleus. In an atom, the number of positive protons is the same as the number of negative electrons. So this is the new point that you are going to learn now. What does it say? In an atom, the number of positive protons is same as the number of negative electrons. That means if an atom has 6 protons, then it will have 6 electrons. So protons have positive charge and electrons have negative charge. So they are equal in number. So when you combine together 6 plus and 6 minus, you get the value 0 in mathematics. But here, what is this 0? Here it indicates in science, it is neutral. That means it has no charge. An atom has no charge. An atom has positive charge protons as well as negative charge electrons. But when you take the atom as a whole, it is not charged. It is neutral because of the concept that number of protons are equal to number of electrons. Children, this slide explains you why an atom is electrically neutral. So in an atom, it is neutral. Why? So as we have discussed previously, most atoms are electrically neutral, meaning that they have an equal number of protons and electrons. The positive and negative charges cancel each other out. Therefore, the atom is said to be electrically neutral. Look into this diagram. In this diagram, it is the representation of the beryllium atom. Okay, this beryllium atom has the nucleus inside, where you have the nucleons. What are the nucleons? The positive charged proton and the neutral neutrons. Now each of them are being colored. You see the positive charges are colored in green color. Count the number of green colors. So you can able to count 4. is it? Therefore, a beryllium atom has 4 protons which are positively charged, and outside the nucleus, come out of the nucleus, just count the negative signs which is green in color. So again you will come to a number 4. There are 4 electrons which are negatively charged. Okay, so since this beryllium atom is having 4 protons and 4 electrons, the beryllium atom is said to have no charge, and that's why we call it as neutral. And what about the other particles which has no charge? We call it as neutron. So when you count the neutrons, 1, 2, 3, 4, 5, there are 5 neutrons. You may ask, it is exceeding, whether it is exceeding or whether it is less. They have no charge. They have nothing to do with the charges because they are neutral. Okay, you have to see the positive charge and the negative charge. For both positive and negative, there are 4 each. Therefore, they cancel each other and the atom is electrically neutral. Okay, children, this slide gives you about the history of the 3 subatomic particles that we have seen. What are the 3 subatomic particles? Positively charged proton, negatively charged electron, and neutral neutrons. Now, protons is discovered, it was discovered by Rutherford in the year 1911, and the experiment in which he found out proton was gold foil experiment, which you will learn in your higher classes. Similarly, the negatively charged electrons were discovered by Thomson in the year 1897, and in the experiment of the response of cathode ray tube to a magnetic and electric field. And the experiment you will learn when you go to your higher classes. And the last one, the neutral neutrons. That's why it is called as neutron. Neutron is a word derived from the word neutral, which means no charge. They were discovered by Chadwick in the year 1932 in an experiment of bombarded Be. Be here represents beryllium with beta radiation, and a neutron was released. So the experiment you need not remember, but the scientist and the year they carry important. Children, this slide gives you the different properties which are the subatomic particles of an atom. So look one by one. Proton. The symbol for proton is small p with a plus sign on the top, and it has charge of +1 because protons are positively charged, therefore their charge is +1. How much is its mass? Its mass is said to be 1 AMU. What is this AMU? A stands for atomic, M for mass, U for unit. So atomic mass unit. Protons have 1 atomic mass unit. And where the proton is located? It is located in the nucleus. And what work it do? What is its function? since it is a positively charged particle, it attracts electrons. Okay. Now similarly we will see to the properties of neutrons. The symbol is small letter u and with no plus and no minus because it is neutral. The charge, as it is neutral, it has no charge, it is 0. And its mass is 1 AMU, that is atomic mass unit. And where is it located? Exactly at the nucleus. And what is its function? It buffers P plus to P plus repulsion to help stabilize the nucleus. Just remember, it stabilizes the nucleus by a interforce of attraction. Then the last one is the electron, which will be exactly opposite to that of protons, and its symbol is E minus and charge is -1 and its mass is 1 by 2000 AMU, atomic mass unit. And where is it located? Electron cloud. Cloud means shell here. Electron cloud around the nucleus. And what is its function? Participate in chemical reaction. A very, very important point you have to remember. Electrons are the one which participate in the chemical reaction. We'll describe this in detail when we go to the next chapters. So this table gives you the collective informations about the 3 subatomic particles. And what is given outside? Protons and neutrons are collectively called nucleons because they are located in the nucleus. So this we have already seen. AMU, atomic mass unit, is defined as 1 by 12 of the atomic mass of the carbon 12 isotopes. So we'll learn about carbon isotopes in the next classes. Okay children, so these are the basic informations that you must know about the subatomic particles. Now children, we have learnt what is an atom, what is the structure of the atom, who are all the subatomic particles, what charge do they have individually, and what is the charge of an atom whole as a whole. All this we have studied. Now let us extend our study to atomic number and mass number. So each element has 2 numbers. One is atomic number and the other one is mass number. All these numbers are related to the subatomic particles that we have studied: protons, neutrons and electrons. Now look at this right side with the colored Z, A and X. This is the usual way we represent an element. X represent chemical symbol for the element. See down, in the place of X you have Na. Na stands for sodium. Now A, where is A written? On the top of X. The A represents mass number, and we'll see what is mass number later. And down is Z, you find a letter Z. So it represents atomic number. Now take sodium and see, it has 2 numbers. One is on the top of sodium you have 23 and down you have 11. So 23 represents mass number and 11 represents atomic number. So if you have any confusion, compare the 2 numbers. Compare the 2 numbers. The number which is greater is the mass number. Why it will be greater, we will see in the next slides. So this is the basic way we represent an element with atomic and mass numbers. So X On top of it A, and down X you have Z. X represents the symbol of the element, A represents the mass number, Z represents the atomic number. Here in the case of sodium, Na is the symbol, 23 is the mass number, and 11 is its atomic number. So we'll go in detail for this. Students, this slide explains you the atomic number and mass number individually. Just listen very carefully because these two are very important. Atomic number, as we have seen, it is represented by the letter Z. It is defined as the total number of protons present in the nucleus of an atom. So, atomic number refers to the number of protons present in the nucleus. So, the positive charge protons is the number of protons gives the atomic number. For example, if an element has 12 protons, then that element has an atomic number 12. So simply we can say atomic number refers to the number of protons. And we have also learnt the number of, in an atom, the number of protons are equal to number of electrons. Isn't it? If an atom has 10 protons, it will have 10 electrons so as to neutralize, and the atom becomes a neutral. Then why not we say the definition as the atomic number is the number of protons or number of electrons, because both of them represents the same. But in an atom, electrons have a tendency to gain or lose. If 10 electrons are there, in a chemical reaction 2 electrons may be gained or it may be lost. So number of electrons are not fixed in an atom, but whereas the number of protons, they do not transfer from one to another. That's why atomic number has the definition. It is defined as the total number of protons present in the nucleus. And next is that it is defined as the total number of electrons present outside the nucleus of a neutral atom. Of a neutral atom, we can say when the atom is neutral, then the number of protons will be equal to the number of electrons. Then atomic number Z, it can be either number of protons P or number of electrons E, provided the atom is neutral. Now you got the meaning for atomic number. Atomic number is represented by the letter Z. It is the number of protons or it is the number of electrons in a neutral atom. Then we'll go to the mass number. What is mass number? Mass number of an element is defined as the sum of protons and neutrons. So count the number of protons and count the number of neutrons, then the total is the mass number. And that's why in the previous slide I told you mass number will be always greater than atomic number, because mass number is made up of two particles. It is the number of protons and number of neutrons. So if there are 5 protons and 6 neutrons, then 5 plus 6, that is equal to 11. 11 is the mass number of that element. You see to the example which is given at the right side. See, it is the symbol for carbon. Number 12 on the top of it, it is the atomic number. Sorry, it is the mass number. There are two numbers, 6 and 12. So 12 is greater, therefore it represents the mass number. And 6, it is the atomic number. So atomic number is the number of protons. So the carbon has 6 protons, therefore it will have 6 electrons. And how many neutrons it will have? 12 minus 6, again 6. So carbon has 6 protons, 6 electrons and 6 neutrons. Okay, now you have understood the concept of how to calculate atomic number and mass number from the number of protons, electrons and neutrons. Children, this slide gives you the idea how to calculate the number of protons in an atom. Protons are the positively charged particles in an atom. So for any given element, the number of protons equals the atomic number. So remember, the number of protons will give you the atomic number. So for example, magnesium is given 12 with 24, and 12 is the atomic number and 24 is the mass number. And I told you mass number will be greater than the atomic number. Therefore here 12 represents the number of protons in magnesium atom. This slide gives you some examples for calculation of the number of protons. Carbon has 6 as its atomic number. So the same 6 will be the number of protons for carbon. Similarly, iron, whose atomic number is 26, has 26 protons. Nickel, whose atomic number is 28, has 28 protons. So as iodine with 53 atomic number has 53 protons. Barium with an atomic number 56 has 56 protons. So in short, the atomic number gives the number of protons in an atom. This slide helps you to calculate the number of electrons. Previously we have seen about the calculation of protons. Now it is the calculation of electrons. For any given element, the number of electrons are equal to the number of protons. We have seen in a neutral atom, the number of positively charged protons will be equal to the number of negatively charged electrons. So both of them should be equal in number. So the atomic number of an element will give you the number of protons as well as the number of electrons. So for example, here magnesium with atomic number 12 and mass number 24. So the 12 is the atomic number. So 12 is the number of protons and 12 is the number of electrons also in this element. This slide again gives you the calculation of electrons in some of the atoms. So carbon, whose atomic number is 6, has 6 protons and 6 electrons. Iron, whose atomic number is 26, has 26 protons and 26 electrons. Nickel, whose atomic number is 28, has 28 protons and 28 electrons. So as the other things. So the number of electrons are equal to number of protons, which is again equal to atomic number. So when we know the atomic number represents the number of electrons as well as the number of protons in an atom. Very simple. This slide gives some information about the atomic number. The atomic number or proton number with the symbol Z of a chemical element is the number of protons found in the nucleus of an atom. It is identical to the charge number of the nucleus. The atomic number uniquely identifies a chemical element. In an uncharged atom, the atomic number is also equal to number of electrons. So these are the facts about the atomic number, which is generally represented here. This slide, children, helps you to understand two things. One is mass number, and next one, how to calculate the number of neutrons in an atom. First, let us see what is mass number. Mass number refers to the number of nucleons. So, in the nucleus, what are the subatomic particles present? Positively charged protons and neutral neutrons. So, these two particles constitute for the mass of an atom. The mass of an atom is given by the nucleons. So it is calculated with the number of neutrons with number of protons. Just you add the number of neutrons and the number of protons, the number that you get is the mass number. So for any given element, the number of neutrons plus the number of protons gives the mass number. So here is an example. Magnesium with atomic number 12 and mass number 24. Leave the remaining. So the mass number is the number of neutrons plus number of protons. From this, let us go to the next part, how to calculate the number of neutrons. The number of neutrons can be easily calculated by subtracting the mass number with the atomic number. So mass number is 24, atomic number is 12. So subtract both these. So 24 minus 12 equal to 12. So on the whole, we can conclude magnesium has 12 protons, 12 electrons and 12 neutrons. Okay, so neutrons can be calculated by subtracting mass number with the atomic number. This slide gives you all the ideas about atomic number, mass number, number of protons, number of electrons and number of neutrons. The element represented here is He, which is helium. So He with the number 4 and 2. Since 4 is greater than 2, 4 is the mass number, 2 is the atomic number. So the atomic number represents the number of protons. So helium has 2 protons. In a neutral atom, the number of protons should be equal to number of electrons. Therefore, helium has 2 electrons. And the number of neutrons is calculated by mass number minus atomic number. 4 minus 2, 2. So helium has 2 protons, 2 electrons and 2 neutrons. This is the general representation of any element X with A and Z as we have seen, where Z is the atomic number which represents the number of protons in the nucleus. X is the symbol for the element. It is one of the symbol. Usually symbols are with the first letter, sometimes with 2 letters. Then mass number A. Mass number is the total number of nucleons, protons plus neutrons. So this is the general representation. X with A and Z. So always whenever you write an element, this systematic representation should be strictly followed. So children, you are being given with two examples for the steps to calculate the subatomic particles. One is with beryllium 9 and 4. So 9 is a greater number than 4, therefore it represents the mass number, and 4 represents the atomic number. So first we can calculate the number of neutrons. Number of neutrons is equal to mass number minus atomic number. 9 minus 4 equal to 5. Then the atomic number represents the number of protons. Therefore, beryllium has 4 protons. In a neutral atom, the number of protons are equal to number of electrons. Therefore, number of electrons in beryllium is also 4. So, overall, beryllium has 4 electrons, 4 protons and 5 neutrons. Let's go to the next example, carbon C and 12. Leave the decimals. So, atomic number is 6 and mass number is 12. Here it is wrongly given atomic number. So, it should be mass number. So, let us calculate the number of neutrons. So, 12 minus 6 will be 6. So, carbon has 6 neutrons. Since atomic number is 6, it has 6 protons and 6 electrons. Therefore, carbon has 6 protons, 6 electrons and 6 neutrons. Children, your activity starts now. So for the next 3 slides, some gaps will be left in between, and those gaps you have to fill it. For example, here you see in this slide, the atom name of the element is given. The proton columns are completely blank. Neutrons as well as blank. Electrons are also blank. Where you are given atomic number and mass number. So with the help of atomic number and mass number, you have to fill this slide with the number of protons, neutrons and electrons. So this is a home assignment. So find out the answers, fill the box and text me this box or photocopy or send me the snapshot of this to my personal number. Okay. In a similar manner, like the previous chart, here is another slide where there are blanks for atomic number and mass number. And what are the informations you are being given? Number of protons, number of neutrons and number of electrons. So with the help of the given things, find out the mass number and atomic number, and as usual, fill and take a snapshot and then send it to my personal number. Children, here is the next home assignment slide. What is given here is you have 5 particles, or we can call it as elements A, B, C, D, E. For each of the element, the number of protons, number of neutrons, number of electrons are given. What you have to do is to find its atomic number and mass number. Not only that, after finding the atomic number, use the atomic number to identify the name of the particle A. So if you know the atomic number, you should be able to tell the particle or the name of the element. So if you have any doubt, you can refer to periodic table. So type in the Google search with periodic table. So you have all 118 elements in that with the representation of mass number and atomic number. So identify the element A, B, C, D, E, and as usual take a snapshot and send it to my personal WhatsApp. Children, here we come to the end of today's class. So as I told you in the beginning, we have seen about the structure of atoms, which is a very important topic. So to revise, an atom is spherical in shape. Spherical in the shape in the sense like a football. It has a center part called nucleus, and the nucleus consists of two particles, positively charged protons and the neutral neutrons. So on the whole, nucleus has positive charge, and the particles inside the nucleus, they are called as nucleons. Therefore, protons and neutrons make up the nucleons. Surrounding the nucleus, we have several orbits in which electrons are revolving around the nucleus. Electrons are negatively charged particles. Mass number is nothing but the number of protons, and atomic number is the number of protons. Mass number is the number of nucleons, number of protons plus number of neutrons. So with these informations, as usual, you have to respond to me. So your response is like the previous classes. So type viewed the PowerPoint presentation PPT with audio. With audio is very important. Without audio, nothing you will understand. So viewed PPT with audio, then type your name and send it in the group. And next, I have given you 3 slides, the last 3 slides as an assignment. The answer for these 3 slides, you take a snapshot. You can draw it in your notebook and you can fill the missing numbers and you can send it to my personal number. Okay children, so that's all for today, and we will meet you next week in the same time. Until then, goodbye to you. Bye bye children.